Thanks everyone. My name is Andy Banta. My official title here at NetApp is Storage Janitor. My role is more like Principal Virtualization Architect, but Storage Janitor is what my business cards say, and I'm not changing it. I was going to say, if you don't like this presentation, just complain to Ask Foskett. He'll take care of it. And if you actually are interested in contacting the Network SolidFire BU, the next generation BU, you can actually contact our Twitter account at SolidFire. That's still up and listening to what's going on the next generation data center business unit. I'm not going to give too much of an introduction of what NetApp SolidFire is. We've been around since 2010. We build all-flash, scale-out storage systems for service providers. There's, I think, 43 different videos on Storage Field Day that have been done previously on SolidFire and NetApp SolidFire. I really don't want to do too much of a full introduction. Just go look back at previous Storage Field Days to make that happen. So what I'm here to talk to you about is the death of the specialized storage admin. And actually, in this case, we're going to pick on the storage admins today.
Is that 3D printed?
You make me cry. It's really sad.
Okay, so the specialized storage admin that is getting buried today is actually going to be the storage admin. So storage admins are evolving an awful lot the same way the server admins did. Kind of like the T-Rexes here, they didn't have a whole lot of reach into the data center. And kind of like these two T-Rexes here, they kind of had an adversarial relationship. But I mean, even since the demise of the database admin, that was kind of the first one to fall completely by the wayside. The specialized admins have been falling off the table left and right. Typically, data centers are looking more for an admin that has what's called like a T-shaped skill set, a broad skill set with depth in one particular field. So I'd like to refer to them as the O-shaped people with T-shaped skill sets. We're going to actually cover a handful of different things. So what actually makes the storage admins less needed, the engineering and business benefits that in some cases might be obvious, in some cases aren't. An awful lot of this is based on the evolution of the storage discipline. Things that have actually caused this to happen are policy-based management. There have been a bunch of different consumers of storage, VMware, Docker, Kubernetes, OpenStack, all have policy-based storage management that allows you to actually set policies on what type of storage you want, and it really doesn't matter what the underlying storage is. The underlying storage has to supply storage that meets those policies. Automation for operating at scale. That's another big thing that has hurt IT administrators for a long time. The coordination between server admins, storage admins, virtualization admins, network admins. It's very difficult to actually do any of this at scale when you have to have all this coordination. When you get to the point where you can actually automate it, you can script it, you can do it through UIs or through scripts, it makes it an awful lot easier, and it allows you to do allows you to administer these things at scale rather than being stuck in little siloed environments. And the ultimate goal of this is to actually deliver self-service storage. The idea that if you, as an app consumer or as an app developer or as a virtualization admin, need to go out and round up some resources to do a project, whether that's a long-range project, whether that's a project that's going to be done tomorrow, doesn't matter. You want to be able to go out and get the resources you need on your own without actually needing to go talk to 13 different admins, because that's not going to happen today. There we go. That was handy. So here are a couple more reasons. So the reasons that the storage admin are going the same way the server admin are almost identical. We have the commoditization of hardware. We have the idea that there really isn't that much configuration you need to do to storage anymore. For a long time, servers were you needed to go out and you needed to buy components from a bunch of different vendors, and you needed to be able to put them together properly. You need to make sure you had the right buses hooked up to your servers. You need to do the jumpers and the wiring and everything correctly. At this point, most people go out and just order servers off the shelf and get exactly what they want. It gets delivered in the box to them. this is making the architectures easier to manage. You just go out and you fill out the checklist of what you need. Storage is an awful lot the same way. You don't actually need to go out and buy this many drives of this size and put them in your box this direction and make sure that you've terminated your buses properly and make sure that you've jumpered them all properly and make sure that you actually have all the software on your host set up to manage them properly. It's just becoming a whole lot easier. The tools to manage them are designed for rapid deployment. You don't actually need to go in and configure. How many people have spent time configuring LVM arrangements on Linux boxes to handle RAID setups? Feel free to jump in and ask me questions anytime as well. As I mentioned, the hardware is becoming commoditized.
QoS and, one defined the channel, structures and things, iSCSI structures, all that stuff has to be defined by somebody.
Right. Well, for QoS, if you can just go in and choose your QoS settings and not have to worry about it a whole lot, it makes it very easy. And for iSCSI, certainly, you can automate an awful lot of the setup. You can add additional storage and not actually need to do any additional configuration.
But you got to set up the IQNs and all that stuff. You got to have.
No, not necessarily. So certainly with solid fire storage, if you buy a new node, you put the node in the rack, you tell the cluster you have a new node, and that's all you need to do.
But you're already running the solid fire management solution at that point, right?
It certainly simplifies things.
Yeah.
And this is actually true of an awful lot of the scale-out storage setups. So Dell EqualLogic had the same type of arrangement. You didn't actually need to go out and assign a bunch of new IQNs to your host to make it work. Scale-out storage works this way because the cluster understands that things have been expanded. You don't actually need to tell the hosts that things have been expanded as well. And a big part of it is the software-defined portions of it where you can actually go in, and if you actually need to add IQNs to this type of thing, you can type the IQN into a script that gets run against the bunch of hosts. You can certainly do the same thing with Fiber Channel. If you have a new worldwide name, you can add that to the scripts, add it to a table or whatever that the script gets run against. Automation is actually helping in all of these cases where you don't need to have somebody who understands what this HBA is and how it works. You can actually just open up the box. The box will say, this device has this WWN. You can add it to an automation script and add it to your hosts. I am pointing out the specific example of NetApp SolidFire, but others can actually use automation much the same way. Do you have a question?
No, just
Okay.
the point of one cluster means one IQN or one destination, so.
Right, exactly. Yep. Some additional reasons why the server admin is going that actually should say the storage admin is going the same way as the server admin, is storage requirements are more dynamic than they ever were. So virtualization came up with the idea that you don't actually need to go out and build up a new physical box to support this workload. Lots of people will build virtual
Load
workloads.
balancing and capacity, storage balancing, and things of that nature.
It still takes some work, but with multi-tenant systems, again, like NetApp SolidFire, the load balancing is taken care of for you. If you put your various different workloads all in one SolidFire cluster, they take advantage of the global efficiencies of scale, and at the same time, the SolidFire system will take care of distributing the load across the various different nodes, so all of your volumes get their guaranteed quality of service. Have you seen the SolidFire 101 slides?
Yes, I am.
Okay. I wasn't going to back up more for you, Ray.
No, I know.
One of the other big things that virtualization brought about was the idea of transient workloads, where lots of times you'll actually have groups that will need a workload that runs for a few days, or if you go talk to our development group over here, if they're testing something new, they will build a VM. They might run it for 2 minutes to make sure that whatever code they changed works, and then will dispose of the VM. That's all there is to it. They don't need to do anything else. And this, if you needed to go out and ask for storage and ask for resources every time that you need to do this 2-minute test, it would make the efficiency of actually doing that test in that much time impossible. So you actually need to work into the idea that there's going to be workloads that come and go, and you should have resources available that you can divvy up for them. This goes into the pace is increasing. So here you are, Ray. So this is actually an example of the various different types of things that you typically need to do to set up a storage system. Various different things in the design, various different things in installation, various different things in the operating. I'm not going to go into all the details. I'm not going to read through this. I'm simply going to contrast it to what we think you need to do with a solid fire system. It cuts down the amount of overhead and development that you need to do by quite a bit. Did you get your picture?
Yes.
So let's go into why the role must evolve. And by evolve, we mean die.
Evolved to death.
So the expectations of what administrators do has changed. So in the beginning, you actually had the availability and reliability. The idea was that I have this workload, I need to build a server for it. The server needs to be available, it needs to have the capacity to actually run the workload, it needs to be reliable, it needs to stay up and running, it needs to have the disk capacity, the storage capacity, whatever it happens to be. It needs to have the CPU, it needs to have the memory, it needs to have the network connectivity. All of these things required somewhat different specialization and possibly required a bunch of different people from a bunch of different departments to put this all together. This kind of gave way to the virtualization age, where you stopped worrying about the reliability of the individual servers. It was kind of like the same thing that happened in RAID shortly before the virtualization age, where it's like, before RAID came along, if you lost a single disk, it was a disaster. RAID went into with the idea that you could actually have a bunch of disks that work together, and if you lose an individual one, you can actually recover all of the information that was there. Virtualization took this approach with what you've actually stored. The virtual environment is the important piece of what you need to save. The underlying stuff that runs it, yes, it should be stable, yes, it should be capable of doing what it needs to, but if it dies, you replace it with something else, and your virtualized workload hasn't changed at all. You can run it on some entirely different hardware. People started getting used to this virtualization idea, where they could actually build up virtual workloads and run them wherever they needed to. And when they started potentially talking to their IT departments, and our IT department said, well, that's nice, but we don't actually have the capabilities for you to do that right now, people started looking around saying, oh, hey, there are these services out here on the web that can actually run this workload for me, and I don't even need to talk to my internal IT department. And this has finally given way to the whole idea that you have an application and you don't really care where it runs. Or you have something that you need to run as a service and you don't really care where it runs. It can be on your internal IT department, it can be on the cloud. You need this application to run. It's how much do you care where stuff runs on your phone? If something is running on your phone, does it matter if it's running in your company's data center? Does it matter if it's running on the cloud? It doesn't matter. The only thing that you care about is that it's accessible in your pocket. So this is kind of the transition from what we call the legacy data center into the next generation data center, where you don't have single tenants, you don't have individual workloads, that you have a bunch of different tenants running mixed workloads, all sharing the same infrastructure. The infrastructure, if you have additional demands on the infrastructure, you simply increase it out to be larger, and you have all of these multi-tenant mixed workloads use its entire infrastructure, rather than saying, oh, I have to prop up this new silo of storage and compute and whatever to run this workload. You get capacity on demand, so typically you over-provision it. So when you run into these transient workloads, and then you run into a QA department that says, oh, by the way, we need to run these 100 tests over the weekend, you typically will have the resources to do it. It's software defined, where the resources could actually move from one place to another. This is one of the classic examples of this is one of SolidFire's customers that has 3 of our clusters, and they actually script when they actually want to move nodes from one cluster to another, just to meet the needs of those different clusters at any given time. Self-service, I'm pretty sure this customer actually has a portal that they can go into to actually just do this, rather than have somebody go in and re-rack and rewire the clusters to do it. And when you get into scale, automation is a catch-all phrase, but when you get into the scale of an awful lot of things that happen, you just need automation because there's just too many objects to pay attention to be able to see on the UI, to be able to make sense of. So automation is going to be the only way that you can actually do an awful lot of these at-scale tasks. So this is just an example of where we actually think things currently are, where you could potentially have two different consumers of a data center, and they're not going to necessarily have predictable results because their neighbor down the hall might be running a certain workload on one day and a different workload on another. They might have to go out and order new equipment to actually get the acceptable performance on all of them. And it's entirely possible that while they're off ordering this equipment, there could be somebody 2 floors down that actually has an all-flash array that they've put 2 test workloads on that nobody else is touching. So everything is separated, siloed. They have various different tiers of storage, and they just aren't making the best use of it. And this ties the storage policies to the physical capabilities of the disk. This is where the tiering comes in, where it's like this workload works best on this type of storage, this workload works best on this type of storage. Almost all the virtual disks are treated the same. You typically just go out and carve out a new VMFS when you need it, throw a bunch of VMs in it, and all of those VMs get treated the same way. Lots of times there won't be much of any control or visibility on the array, and it requires an awful lot of, let's see, we need this much space, so we need to go carve it out of this array, or we need to move these VMs from this VMFS to this VMFS to make it work. An awful lot of this discussion is going to be very VMware focused, just because I've spent way too many years at VMware. I'll touch on a handful of other technologies as well, but most of this discussion today is actually going to be VMware focused. So here, what we actually wanted to get to is the idea where you actually can guarantee per application performance. This isn't like per VM performance, per application performance, per virtual disk performance. Immediately respond to changing needs. A great example of this is if you actually have an application server that's running and it has certain I/O requirements, and then you want to do backups at night. Well, if you've already set it to run at that certain I/O performance that the application needs, a backup is going to kill it. So why don't you just adjust it immediately to handle the backup load, and as soon as the backup is done, readjust it to back where it was. And you can do this automatically through the exact same software that's running your backups. So the backup software can say, adjust the IOPS, do the backup, readjust the IOPS back to where they were.
This is through vVols, or?
This is through, I'll be showing how you can do this with vVols, but you can do it on a VMFS level today. If you actually have individually attached disks with SolidFire that are iSCSI attached to the guest, you can do that today. That's what an awful lot of people do today, where the individual disk needs certain IOP loads during the day, and they do backups at night, and they will adjust the IOPS for that individual disk while they're doing backups, and then readjust it back.
Using something like vRealize ops or REST?
In the case of a direct attached disk, it would actually just be using the SolidFire API. And this allows you to dynamically manage storage and applications. So if you have a bunch of different applications that run at various different loads, you can actually change them. Again, we're talking about virtualization, but match disk performance to the workload. So if you're running flat applications, it runs it as if you're running flat applications plus backups, it'll get adjusted for that. And again, you can automate it through your backup scripts or whatever else.
Are you guys working with today or looking to work with any backup vendors to try and make that more native, rather than, say, an admin going out and scripting it themselves based on the tool sets they have, maybe actually getting integration with some of the big players in the backup space to be able to do that? So,
I mean, we have some integration with Commvault and with Veeam already. I think there's another vendor.
Data.io as well.
I'm sorry, which one?
Data.io.
Data.io. was another one that SolidFire is working with, and I don't think that it's any secret that we're actually working quite a bit with NetApp NetApp SnapMirror. So once we get integration with that, an awful lot of the backup capabilities that are available through NetApp SnapMirror will be available to NetApp SolidFire products as well. It's been longer in coming than it should have, but there we are.
And through that integration with those backup vendors, they can actually change the IOP requirements in real time while the backup runs? Is that?
I don't know if they actually have the integration to do it themselves, but typically what would happen is the person who was configuring the entire system,
The storage admin.
that guy, yeah.
This guy here? Yeah. That's dead.
Yeah, or the virtualization admin. Because this isn't actually real storage admin work. This is making sure that your virtual environment performs the way it
Well,
should.
IOPS, balance, these are storage things.
But do you need 40 different admins to do it all?
No.
Okay. So along the same lines, nobody misses being focused on server administration. We'll eventually end up with the idea that nobody needs to be focused on storage administration or database administration or network administration. If you can get at the point where there's a bunch of different tasks you need to maintain your data center, and you don't need to go say, hey, how do you do this with 40 disks and 16-bit SCSI bus, it becomes easier. It certainly makes the value of virtualization administrators higher, and it also puts more workload on the virtualization administrators if the virtualization administrator is the person who's kind of divvying up what the virtual environments are and how applications users are using them. I'm not sure exactly what I was going for with the higher value activities exist for storage discipline as well, but so one would certainly hope that if you're a storage admin, that you have some desire to go out and learn additional things and become valuable in an IT organization. So one of the things that NetApp SolidFire has tried to do is make sure that this is enabled through integrations with both APIs and tools. This is actually some very obviously Josh Atwell artwork, and Josh gets a huge shout out for taking a bunch of random ideas and slides that I kind of jumbled together and actually attempting to form a coherent story from it and adding little graphics like this. So if you actually think that anything is cute and interesting in here, you can probably bet that Josh added it. This is the whole idea here is that through the APIs and tools that NetApp SolidFire includes, you can do things like set QoS policies on the fly, create and destroy VMs if you're using vvols, or data stores if you're simply using traditional VMs, or if you're using entirely different systems entirely. You can create and destroy the volumes on the fly at your will, anytime. And you can see here the various different integrations that SolidFire has to work with various different vendors and scripting packages and whatever to allow you to do whatever you need through tools and integrations with virtualization concepts. So this was actually just a little bit more of evolution of storage. Maybe this should have been moved up a little bit, but this is originally the storage discipline was, this is actually a picture from my boneyard at this point. It has jumpers and SCSI connectors and terminators and SCA adapters and whatever else. And I luckily found a screenshot tucked away in one of my old things of actually using some mirroring software on the Sun system. This is the type of thing that used to be the type of thing you did every day to make sure that your system would stay up and running and it had its data available. And it's like you'd run a script every day that would go in and make sure that the state of both submirrors was okay, and if it wasn't, you'd need to go fix it. This is moved over to the idea where you rack and stack nodes, and once the cluster is set up, it's ready to go. it will come back and tell you, hey, this node is down, this disk is down, fix it. And in fact, if you actually allow it to call us, your support guy will call you in the phone and say, hey, there's a disk in your cluster that needs to be replaced. That combined with the vSphere web client should be the only tools that you actually need to actually administer a virtual VMware environment on solid fire storage. I'm going to show you a demo in a little while that actually uses entirely the vSphere web client to manage creation, destructions, setting QoS, creating data stores on a SolidFire cluster. And while I'll show you a couple things in the SolidFire UI, we're not actually going to do anything in the SolidFire UI other than just look. And this ties in nicely to how VMware simplifies storage administration. VMware has a bunch of integrations. Storage I/O control, something that NetApp has tied in with our own QoS. The vCenter plugin, which allows any vendor to provide a piece inside vCenter that allows you to manage that vendor's products. Storage policy-based management, huge piece. The whole idea that you can actually set policies for your VMs and for your virtual disks in vCenter and have that reflected on the storage automatically, big thing. PowerShell integrations, the idea that you can actually go out and write little scripts that will go out and touch vCenter and touch various different pieces, other pieces of your infrastructure, and be able to do it from one centralized place is important. vRealize Orchestrator and Automation are a couple of other VMware products that allow you to go out and automatically deploy duplicate VMs over and over, be able to set various settings on them.
And is the storage policy management, is that only available with vVols, or is it available with regular VMDKs and stuff of that nature?
It's not currently available with VMDKs on SolidFire systems. If anybody actually has a VASA provider that does the policy management and has it tied with VMFS, yes, it can certainly be done that way.
Yeah.
So storage policy-based management is actually done through a VASA provider.
Not through vVols, yeah. But I mean,
And well, vVols counts on the VASA provider. So
Right.
if you implement a VASA provider, you can have it work on VMFS volumes only. So any of the vVols calls that are made into it will simply get returned as not implemented. So storage policy-based management goes hand in hand with vVols. And in fact, whether you know it or not, you're using storage policy-based management anytime you're using vVols. Only an awful lot of people tend to ignore that. So policy-based management, the rescue, this is the idea that you can actually go out and set policies from your platform, whether that's VMware, Docker, OpenStack, Kubernetes, and have that reflected on the storage automatically. This is one of the biggest ways that you can obviate the need for a storage admin is actually allow the application or the platform owner to be able to set the requirements for the storage and have the storage automatically deliver that. This tied in with automated management or automation and management for scale is another big piece. One of the things I'll show you with my vVols demo is the number of vVols that you end up with is far greater than the number of volumes that you would typically end up with on any other given piece. And the only way that you can actually manage any of this stuff is to be able to, have scripts that run against a bunch of different things or have applications. We have customers who have complete GUI front ends that go in and manage their entire infrastructure because attempting to do it by hand would just plain be impossible.
how many LUNs does SolidFire support today, and how many vVols do they support?
How many LUNs, as in volumes?
Yeah, volumes, yeah.
I believe it's 2048 regular volumes.
2K, okay.
Yeah, and 8K is the soft limit for vVols right now. The limit was originally stated as 2K per node. And
Andy, 10,000 regular volumes per
10,000
cluster.
regular
10,000 regular volumes? Okay, thank you. I stand corrected.
And
It
8,000
had been
vVols?
2,000, hadn't it? It had been 2,000 before.
Maybe before I got here.
And it's 8,000 vVols?
And it's 8,000 vVols, but that's a soft limit. We've certainly gone above that. It's simply an as-tested limit. So the whole goal out of all this is the delivery of self-service storage resources.
Does that make sense, Andy, to have 10,000 volumes and 8,000 vVols? It doesn't seem like it makes sense to me. If you could support 10,000 volumes, why couldn't you support 80,000 vVols?
vVols is a version 1 feature right now. That's the
sorry.
reason. This is our first version of vVols that's shipping in our current code, so that number will go up over time. It's just first version out the door, 8,000 is where we got to.
Okay, and I've done all the disclaiming I'm going to, that we know it goes over 8,000 already. It's simply that our QA could test up to 8,000 and say that we get 8,000 to run comfortably. And I know I've seen labs that have run higher than that.
Yeah.
So it's an as-tested number. Just a couple examples of other different things. So if you actually want to use Docker, there's complete integrations with NetApp to be able to create it from a Docker script, have it made available to you. You create a number of volumes, create a LUN, various different types, and or you can actually use this to connect to an existing volume. So this is, again, one of the integrations of Docker with NetApp SolidFire to automatically provision volumes on the fly without any interaction whatsoever with the storage. Trident integrates with Kubernetes, so it does the same type of thing, allows you to, it actually works with both ONTAP and SolidFire. It goes in through the Trident package the NetApp team has worked on and allows you to create volumes on the fly from Kubernetes and have them automatically provisioned on the underlying storage with absolutely no interaction from the storage admin. We also have some monitoring and various different storage classes that you can set up as well.